Hello, let me tell you about an exciting project that we did in collaboration with GTK about detecting acid sulfate soils. Acid sulfate soils is a special type of soils right under our feet, which are very good for agriculture, like on this experimental farm, or are situated in nice places when people like to build cities and villages, but they require special treatments. So it's very important to know where exactly we have those. Unfortunately, these soils are not located uniformly. We need to know the precise location, and for that we can use a map. For example, here is a Google map with that little house right next to which we are now shooting this video. We can go to the GTK estimated map that says that we might be in an area with high risk of finding acid sulfate soils. But do we really have those soils or not? If we want to know for sure, we need to drill a hole in the field, take a soil sample, send it to a laboratory, and a week later we'll get the result. But that process is very slow and expensive. And besides, GTK have done it thousands of times over last decades. So now we can use this knowledge to speed up the process. And for that, we use the power of machine learning, or as it's called now, AI. We can ask machine learning to build us a computed map of acid sulfate soils from all the available satellite data, map data, radar scanning data, and a lot of other sources of map data that we have today. And here is a predicted map. So this map is not bad, but there's one trick. But you know your area much better, and you know your area better than the default map that everyone has. So how we can make this map better? If you would be a researcher or a scientist, you would take measurements about a place that you know. For example, you have dug this ditch and you haven't seen acid sulfate soil. So you know that this place has normal soils for sure. A scientist can add this to a dataset and train a machine learning model and generate your predictions, but not everyone is a scientist. But now this app helps everyone do the same stuff by being just a regular person. You find a point on the map where you know is, for example, not an acid sulfate soil, and you mark it as this is normal point. When what the map does, it adds your point to the dataset, and it computes a new model and it recomputes the map. And now you have an updated version of the predictions that says that despite being high risk area, most of the soils around here should be fine if you in one place have seen that there are no acid sulfate soils. Maybe you can go to another place and you saw that there are actually acid sulfate soils, you mark that. Then the app updates the model and says, oh, that doesn't affect so much your field, but the nearby field might be at a high risk. So that is a way of interactively using machine learning for solving the very practical problem of detecting acid sulfate soils that we wanted to present to you today. Thanks for your attention.